Hello again. We are continuing our discussion on graphing linear equations by talking about rate of change and slope. Very important with lines. All lines have a slope, and it's nice to know what that slope is. Rate of change, what is that? That is how one quantity changes as another quantity changes. So in other words, how quickly is one variable changing as the other variable changes. Okay, so if we call those two quantities x and y, then rate of change is the change in y divided by the change in x. So how quickly is y changing as x changes? Okay, and if we have two x's and two y's, that would really help. I can call one of the y's the new y and the other one the old y. I can call the two x's the new x and the old x. And using those four numbers, I can figure out how quickly a line is changing, how quickly the variables are changing in relation to each other. So here's a graphing example. Okay, I've got the line there. I've got 3 points, 0, 5, 3, 3, and 6, 1. All of those are on the line, so I can figure out the slope of this line by considering any 4 of those numbers or any 2 points. I have to be specific about how I choose them, though. I can't pick them in whatever order I want. So I'm randomly going to pick 0, 5, and 6, 1 as my 2 points. You could choose any 2 points and this would work, and I'll show you why, how that works a little later in this video. So I'm going to randomly let 0, 5 be the old x and the old y, and I'm going to let 6, 1 be the new x and the new y. And I'm going to use that formula that I just talked about, new y minus old y over new x minus old x. Okay, so the new y is 1 and the old y is 5, so I put 1 minus 5 on the top. The new x is 6 and the old x is 0, so I put 6 minus 0 on the top. And I calculate. 1 minus 5 is negative 4, 6 minus 0 is 6, so I get negative 4 over 6, which can be reduced to negative 2/3. I want you to remember that number. That number represents the slope of this entire line between any 2 points. So let's think about how another way to talk about slope. We sometimes talk about the change in y. We call that the rise, because as you go from one y to another y, you are rising. You are either going up or you are going down. And we call the change in x the run, because as you go from one x to another x, you are either running left or you are running right. You're going across. So the slope is called rise over run. You'll hear that a lot. Rise over run is what we mean when we talk about the slope of a line. So if I'm going from 0, 5 to 6, 1, I'm just going to draw some arrows in here to show how far I go up or down and how far I go left or right. So if I'm starting there at 0, 5, I need to get to 6, 1, so I need to go down 4 spaces to get there. Okay, so we consider that negative 4. That's a rise of negative 4. Since I'm technically not going up, I'm actually going down. And then how far do I run to get the rest of the way to 6, 1? I have to go across to the right 6 spaces. Okay, so that is a positive 6 because I am going to the right. So rise over run would be negative 4 over positive 6. That's what I got the last time, negative 4 over 6, and I reduced that to negative 2/3. So that's another way to think about slope. You can pick 2 points and just count how far you would have to rise and how far you would have to run to get from one point to the next. And it really shouldn't matter which 2 points I use. So let's say I'm using 2 different points, 6, 1 and 3, 3. So now I'm going from 6, 1, that's the old x and y, to 3, 3, that's the new x and y. So how much do I rise? How far do I have to go up or down to get there? I would have to go up 2 spaces to get there. So that's a rise of positive 2 because I am going up. And then to run, to go across the rest of the way, I have to go left 3 spaces. So since I'm going left, that's a run of negative 3. Slope is still rise over run, so that's going to be positive 2 over negative 3, which is negative 2/3. That's the same thing that I got both times when I was calculating it with the numbers and when I was using the little arrows the last time. So the slope is still negative 2/3. It doesn't matter which 2 points you use, as long as you do it correctly, you should get the same slope on a line every time. So here's how I determine whether something does actually make a line or not. In order for that to happen, the slope needs to be the same no matter which points I'm talking about. So I'm looking at the slopes between each pair of points. First, I'm going to look at negative 3, 5 to negative 1, 1. Okay? The change in y from 5 to 1 is negative 4. The change in x going from -3 to -1, that's a change of 2. So rise over run is -4 over +2, and that is -2. Now let's look at the next pair, -1, 1 to 1, -5. The change in y goes from 1 to -5. That's a change of -6. The x's go from -1 to 1, and that's a change of +2. So rise over run is -6 over +2. That's -3. Okay? So just looking at two different sets of points, I've got two different slopes. One time I got -2, the other time I got -3. So what that means is, since the slopes aren't the same everywhere, this is not a line. If I were to graph those points, it would not make a line. Okay, here's some special cases. A horizontal line, every horizontal line has the equation y equals some number, because you have to go up the same number of spaces to get to a horizontal line. It doesn't matter how far you go across, so x can be whatever you want, but you have to go up a certain y value to get to that horizontal line. So for example, y equals 2. All of those points you would have to go 2 spaces up to get to that line. Okay, so to talk about slope, there's no change in y, but there is any amount of change in x, so I've got a rise of 0 over a run of whatever I want. 0 over anything is 0. So on a horizontal line, the slope is 0. Now let's talk about a vertical line. Every equation of every vertical line is x equals a number, because now I'm going across a constant amount of spaces to get to that vertical line. So for example, if I have x equals -4, I would have to go across 4 spaces to the left in order to get to that line, but I could go up or down as much as I wanted, so y really doesn't matter. Okay, so there's no change in x at all between any points on that vertical line, and since y can change however much you want, and there's 0 change in x, I've got a number over 0 as my slope, and you can't have a number over 0 as anything, so that slope is considered to be undefined. All right, so here's a real-life example of slope. I have Douglas. He's traveling down I-35. After 2.5 hours, he passes exit 234. And then after 5.5 hours, he passes exit 459. And as you know, the exits on major highways are numbered based on how many miles along that highway you are. Okay, so what's his average speed? I'm going to use ordered pairs where x is the time that he traveled and y is the exit number. So 2.5 and 234 pair up together, and 5.5 and 459 pair up together. So I can subtract the y's and get 225. If I subtract the x's, I get 3. So the rise is 225, the run is 3, so slope is rise over run, 225 over 3, and that is 75, and that means that Douglas is traveling 75 miles per hour. So there's a practical application of slope. We'll be talking more about this tomorrow, but if you have any questions, please let me know, and I will see you tomorrow.